He always supports the students, gives our college dedication and discipline to kindly come up with
I now request the Revered and Dynamic Professor O. Muhammad Hussain sir to kindly grace the dais with his esteemed presence. Please join me in welcoming him with a warm and thunderous round of applause. A very warm and wonderful morning to everyone. As we begin our Space Week celebration, it is time to invite our dignitaries on the stage. We are blessed with a leader whose teaching makes the most complex concepts simple, and she does not teach just to teach us. She cares our future like a mother and builds our character with a discipline and treats every single student of her own family. She is, in every sense, the main pillar of our department. With endless love and deep gratitude and the highest respect, we kindly request our beloved HOD, Sri Uma Devi ma'am, to take
Program starts with prayer. Bhakti, Reddy Sirisha, Priyanka, Harika. Second verse.
गणनायकाय गणदैवताय घनाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि
Introduction of the chief guest by B. Gyaneswari, third BSc Physics.
Om Namo Venkateshaya. It is an honor for me and an immense pleasure to introduce our chief guest of today's Space Week program, Professor O. Muhammad Hussain Sir, Thin Film Laboratory, Department of Physics, SPW University, Tirupati. Here is a brief introduction of his biodata. Dr. O. Muhammad Hussain Sir is a distinguished Indian physicist and professor in the Department of Physics, Sri Venkateshwara University, Tirupati, specializing in thin film technology, material science and nanotechnology. He obtained his BSc in 1982, MSc in Physics in 1994 and PhD in Physics 1990 from Sri Venkateshwara University. He completed his post-doctoral fellowship 1991 to 1992 at University Pierre at Marie Curie, Paris, France. With over 35 years of research and 29 years of teaching experience, Dr. Hussain Sir has made significant contributions to the development of transition metal oxide, thin films, lithium-ion batteries, solid-state microbatteries, supercapacitors, electrochromic devices, and gas sensors. He has established advanced thin film deposition facilities in the department and successfully led several major research projects funded by DRDO, DST, and UGC and other national agencies. Dr. Hussain Sir has published more than 190 research papers, authored 2 books, guided 21 PhD scholars and 9 MPhil scholars, and organized several national conferences. His research has earned an H-index of 39, I-10 index of 134, and over 5,100 citations. He has received numerous honors, including the INSA Visit Fellowship, Teacher of Excellence Award in 2009, Distinguished Leader in Science Award in 2018, National Mentor Award in 2018, and several Best Paper Awards at national and international conferences. Dr. Hussain Sir has held several important academic and administrative positions, including Head Department of Physics and Dean University Department, Head in Charge University Science Instrumentation Center, and Registrar of Sri Venkateshwara University. He has also served on boards of studies of several universities and is a life member of leading professional scientific societies. His current research focuses on nanostructured materials and thin film technologies for advanced energy storage devices, including lithium-ion batteries, supercapacitors, smart meters, electrochemical sensors, and gas sensors. I thank our principal madam and all my physics faculty members for giving me such an opportunity. Thank you.
Thank you, ma'am.
Om Namo Venkateshaya.
Om Namo Venkateshaya.
With great respect and admiration, I introduce our principal madam, Dr. T. Narayana Magaru, whose vision and dedication has shaped the growth and success of our institution, and her guidance has been instrumental in shaping our college progress. Our principal madam is a distinguished academic leader with more than 31 years of UG teaching experience and 6 years of postgraduate teaching. She has dedicated her career to shaping progressive academic environments and empowering women through education. She holds MCom and PhD degrees and has significantly contributed to commerce education through intensive research. Her academic output includes a book published titled Customer Relationship Management, a study with special reference LIC, 7 international research papers and 24 presentations in various national and international seminars. Our beloved madam has an extensive administration legacy, having served as the principal and chief warden at both SPW degree at PG College and also SC Arts College. She has been an active member in key university bodies such as PG Set Committee, Academic Scheduling Committee and Fee Structure Committee of Sri Venkateswara University, Tirupati. Her leadership with the holistic hostels, women's empowerment cell and student welfare committees highlights her commitment to holistic institutional development. She is associated with several professional and social organizations, including the State Awardee Teacher Association and the TTD Women Employees Redressal Cell and International Women Day Celebrations Committee. Dr. T. Narayanama Madam's excellence has been widely recognized. She has been a NAC assessor since 2024. And for 3 times, she is the recipient of prestigious honors such as the Best Principal Award by TTD in 2017, 2022 and 2025. The National Education Excellence Award in 2021, Savitribai Phule Award in 2020, Bharat Mahila Shiromani Award, Indira Priyadarshini Award and AP State Best Teacher Award. She has also received an appreciation certificate from the Ministry of Finance, Government of India for being recognized as a best taxpayer in the bronze category. Her tenure has been marked by transformational improvements in infrastructure and academic quality. She has championed initiatives related to hygiene, safety and modernization of college facilities. Our principal stands as an inspiring academician, administrator and mentor whose vision continues to uplift educational standards and empower future generation of women. Thank you, madam. Thank you for gracing our day program today. Thank you very much.
Thank you very much, ma'am. Next, keynote address by Dr. C. Umadevi.
Om Namo Venkatesaya.
Om Namo Venkateshaya, ma'am.
Respected Principal Madam, today's Chief Guest Professor Hussain Sir, faculty members and dear students, very good morning to you all. It is my pleasure to welcome you all to the Space Week celebration organized by the Department of Physics, SPW College, Tirupati. The theme of World Space Week 2026 is Rocket Revolution. This Space Week is celebrated globally. The theme Rocket Revolution focuses on the rapid transformation of space launch technology, exploring how new vehicles have made access to orbit more affordable and open space to a new generations of missions. The main objective of celebrating Space Week is to create awareness about the importance of space science and technology in our daily life and national development. This program aims to inspire students to develop scientific thinking, innovation, and curiosity about the universe. It also highlights India's remarkable achievement in space exploration and motivates students to pursue careers in science, research, and technology. Through activities such as quizzes, exhibitions, poster presentations, elocutions, etc., we hope to encourage teamwork, creativity, and a spirit of inquiry among our students. Remember, today's students are tomorrow's scientists and innovators. So I encourage you all to participate actively, learn something new, and be inspired to dream big. Thank you, and I wish you all a successful and enjoyable space.
Thank you very much, Mama. Next, address by the Om Namo Venkatesaya. It gives me an immense pleasure to welcome you all for this Space Week celebrations. Today we gather here not only to celebrate the wonders of space, but to inspire the curiosity, innovation, and scientific thinking among our young minds. As Indians, we take great pride in the achievements of the ISRO, who have brought their missions to the global recognition to our nation. The success of mission demonstrates that with great vision, dedication, and great teamwork. These achievements inspire our students in a great manner. That to inspire students in several ways. What is that? The success of mission, like what are those Chandrayaan, Mangalyaan, and Aditya L1, demonstrates that with great teamwork, dedication, and great vision. Okay, these kind of achievements inspire you also. In what way they inspire? In what way? Tell me. ISRO, how ISRO can inspire you? Teamwork, hard work. Important thing చెప్పలేదు.
To know more about space.
Space, next. Scientific thinking, etc. Okay. So, girls, you remember that every great scientist was once a curious child. Curious child. So that you must have curiosity. Do you know? You must have curiosity. That means how, why. You have to ask like these questions. Then only you have to develop, you can discover something. కాబట్టి మీరు ఎప్పుడు కూడా ఏం చేయాలో ఏదైనా చెప్తూ ఉంటే సైలెంట్గా వినడం కాదు. యు హ్యావ్ టు ఆస్క్ ద క్వశ్చన్స్. ఎందుకు ఇలా అయింది, ఎందుకు ఇలా జరిగింది, ఏంటి కారణము, వాట్ ఆర్ ద రీజన్స్ అనేది మీరు హ్యావ్ టు ఆస్క్ సచ్ టైప్ ఆఫ్ క్వశ్చన్స్. ఎనీవే, దిస్ ఈస్ గుడ్ ఆపర్చునిటీ ఫర్ యూ టు పార్టిసిపేట్ in various competitions. Those are it may be essay writing competition, elocution competition, debate, quiz, etc., which are to be conducted by the physics department. So that I sincerely appreciate the entire staff of the physics department for their dedication in organizing such kind of celebrations. Thank you very much. Next, I request our chief guest, Professor OMD Hussain Saab, to address the gathering.
Respected principal, Srimati Dr. P. Narayana, Head of the Department of Physics, Dr. C. Umadevi Garu, the members of the Physics Department. I think most of them are my students. Good morning to all.
Good morning, sir.
came several times to your college. Several times. As an examiner, I came. As a mentor, I came. I have given many lectures also. Participated in many inaugurated functions too. I am the person who was instrumental in getting autonomy for your college as Register of Sri Venkatesh PHY Zone. And another thing is, my missus, my wife, she studied here, ex-student of this college. Here. So that's why I have a lot of ability. When your teachers came and asked just day before to give a lecture for the students, then I immediately accepted. Because it's like coming to a very intimate, college, and where I could able to share my thoughts and ideas with those students, please. It's a great honor for me to be the chief guest of this function. Maybe I will give about the space exploration and all these things, maybe why we have to, and what are the essentialities, how we learn the space and all these things, maybe in my English presentation, but anyhow, generally, a general idea I will just give. Knowledge is power. Knowledge is power. That too. Ladies, ముదితలు నేర్వగరాని ఇచ్చడంటే ముద్దారగానే ఇచ్చిన మీకు ఒక సమయస్ఫూర్తితో ఒక విజన్తో నేర్పిస్తే మీరు నేర్చుకోలేని విద్యంటూ లేదు. ఇది వెరీ ఇంపార్టెంట్. అండ్ ఎనీ ఇన్నోవేషన్ starts with the requirements and the necessities. If you see from the very old era, people struggle for the food and struggle for the comforts, and automatically the technology, the science and technology has been evolved and developed. If you just observe our old Puranas, whether they have happened or not happened, they are written, that's a different issue. But you see, in the Ramayana, Ravana travels in Pushpak Viman. That means the people have idea about traveling in space from one place to the other place. And we also observe in Ramayana that Sri Anjaneya Swami, he wanted to eat because he thought that sun is a fruit and he wanted to eat. So Akasudaki Yagarugayana happened, but see the idea or thought of Valmiki, how he has just impressed. And see the Ramaban, the power of the arrow, power of the arrow, that how it just goes and then hits the target in a specified time, and whatever may be the length from the observer to the object. Similarly, if you just observe in Mahabharata also, there are several issues. When the war was going on, and because Krishna is a blind man, and he could able to see everything, how the war is going on by means of putting anjanam. In those days, they used to see, put a paste over the, then they used to see like a TV screen. Why I am telling all these things? Because here, People, when there is a necessity, when there is a definite requirement, and people struggle for it to innovate the things. So, one of the major issues here is the మేడం కూడా చెప్పారు ఎందుకు ఏమిటి ఎలా అది వాడు కూడా సినిమాలో చెప్పారు సింపుల్గా బట్ మేడం చాలా సింపుల్గా చెప్పారు మనం చదివేటప్పుడు కూడా వాట్ ఈస్ వెరీ ఇంపార్టెంట్ ఈస్ that we have to see in how many ways that we can interpret the statement or a hypothesis or a say for example any equation. For example, when Chandrasekhar was traveling after getting Nobel Prize, he was asked what he wanted to do next. He replied and said that if time permits, I will try to understand Newton's second law of motion. If time permits, I will try to understand the Newton's second law of motion. Who said this? Chandrasekhar, a Nobel laureate. In the sense, how many ways that you can interpret the formula? So, the Newtonian mechanics take the basis and then build up. As assuming that the position, mass and the time are not variable. They have taken it as constant. They are absolute and invariant. The fundamental parameters are absolute and invariant. And the complete Newtonian mechanics has been built. In the sense, for me, the distance from here to there is, say for example, is 10 meters. It is same for me, for you, whether the observer is in motion or the object is in motion. Doesn't matter. And if the mass of this might say, for example, is about 200 grams, it is the same for me and for you if the observer is in motion or not in motion. And the time interval, say for example, I just begin talking to you, say for example from 10 minutes, suppose it is 10 minutes exactly from starting time to ending time, 10 minutes, and 10 minutes is same for you and for me. But see, Einstein just in a different way he thought, and could able to see that there is no absolute and invariant frame of reference in the universe. There is no absolute frame of reference. Everything is relative. So if you are making relative measurements, if the speed approaches to the speed of the light, for example, then you can see lot of difference that you can able to see. That means you can have the time variation. That means if I measure here, say it is 10 minutes, and for an astronaut it may not be 10 minutes, it may be 11 minutes. Or it may be, say for example, I can see where I have just danced yesterday, today, and tomorrow also that you can see. It's dependent upon how you just travel. So I think the twin paradox, length contraction that you might have learned. See the interactions, especially when you try to understand the space explorations here, then why I am just telling all these things is, if you want to travel in space, or if you want to explore the space, the basic ideas are very, very essential. Basic ideas are very, very essential. That means, if you want to know, say for example, what is the simple distance between the moon and the earth, you send an IR beam, and then the IR beam gets reflected, and you measure the reflected beam, and you can very easily measure the distance from earth to the moon or earth to the sun. And the beam which is reflected from the same, for example, from sun, that you can measure the distance, and you can see when it interacts with the matter of the sun, and then you can find out what is the temperature of the sun, And then what are the elements that you can explore there? That the water is present or not in any, say for example, planets, that is one of the important things that you can just do by sitting here, you can do many things. If a rocket has to be, say for example, sent to Mars, for example, Mangalyaan, and then say for example, it just came back to the same place, to the ground, and then if it is say landing at the same, say at the same position, at the same point, then you see, you must calculate the speed and the time and the force and the machine performance, everything relatively. That means astronaut will calculate and you also calculate at the ground and it must match. Without the relativity theory, it is not possible to land the rover exactly at the same point. Because you know, it may be traveling, say for example, at the beginning, maybe 1 lakh kilometers per hour. Then to bring it down and then get it onto a particular position is very, very difficult and important. Otherwise it will crash. Even on the moon also, when you just put your rover onto the moon, then you can see that when it lands on the moon here, we must see the geographical, how the geography on the moon and with what speed that it has to be landed. మీరు బస్ ఎక్కినారు నిలబడాలి బస్సు ఆడినంత వరకు ఉంది దిగాలి లేకపోతే ఏమవుతుంది ఎస్ ఇస్ ద ప్రాబ్లం అండ్ ది గ్రావిటీ వేరియేషన్స్ దట్ యూ కెన్ ఏబుల్ టు సీ లాట్ ఆఫ్ గ్రావిటీ వేరియేషన్స్ ఆల్ ది సో దట్స్ వై ది థియరీ ఆఫ్ రిలేటివిటీ became very, very significant in your space exploration. And people asked, maybe in those days, because understanding theory of relativity is very difficult in those days. And people went and they asked, what is theory of relativity? Then how to justify the theory of relativity? Can you simply say that put your hand on a hot pan, you will feel even 1 minute like 1 hour like 1 minute, then you cannot keep it. Just you can, it's very hard. Even 1 minute, 1 second like you just feel it. But sit with a pretty girl in a garden, you will feel that 1 minute is like 1. Even if it is 1 hour, you just feel it in 1 minute only. Now I say, put it about. So this is it. If two trains are traveling in opposite direction, you see the variation of the observers, how he measures the speeds. It's positive on the same direction and you have to subtract if it is on the opposite directions. So like this, there are many things which are very essential. This is one side of the space. And to go to this space, what are the essentials that you need? How many gadgets that you need? Lot of gadgets that you need. You need sensors, you need motors, you need thermopumps, and you need for the power like solar cells, batteries. And one important thing is that these batteries or the solar cells which you are using in your satellites should not add weight to the rover. Otherwise, no, carrying becomes very, very difficult. Each 1 gram is very difficult. It's not very difficult. Maybe I will show you in my lecture maybe what the space exploration and all these things is. But I will just conclude saying that science, technology, and innovations, these are the pillars where we can invent the things and bring the luxuries to the mankind. And you can fulfill the desires of the human beings for a comfortable life. It's very important. When we just observed when we were at the school level in 1960s, and only one gramophone used to be at, say, the municipality member or something like that, chairman house, and then we use at that time in the radio, we used to listen, go there, and all the people sit there and listen to music. No keys. And to the school, we used to even walk, even if it's 2 kilometers, 3 kilometers, 7 kilometers, we used to walk. But you see how the transformation has been taken place. Now everything is in your hand. The complete world is in your hand. How best that you can utilize this is very important. You can use mobile for conversation. You can use mobile for, if you just open, for example, YouTube or say, for example, Google, you can get anything, all the information. And if you want to write, you ask AI to just write and then give you the answer. Just type the subject what you want. Today, you begin, then later you are here, just these two. And my behavior is like this, how to change my behavior. Of course, one important thing is, because if you have the time AI, it's only created program by the human being again. So, we are the dictators. We are the dictators. And our mind has to dictate our life. So, you control and think innovatively and read whatever you should not read between. You must study and then understand the subject. These are very essential things for a student. Nobody sees your marks now. If you have minimum class, okay, it's all right. And getting 99%, 98%, nobody believes you to go for an interview. People see that how much depth knowledge that you have in this subject is important. So, try to understand the subject and then prepare for the examinations accordingly, which gives you satisfaction. And participate in competitions so that you can realize yourself that what are the capabilities of your capabilities, which is very, very important. Because everybody will have, maybe one may be very good in understanding in one stroke, one may be very good in speaking, and one may be very good in, say, for example, doing laboratory experiments, and one may be having good skills on computer knowledge. So you can explore your ideas and you can proceed accordingly to build your career. This is very important. This is very important. Don't go blindly. I joined for PhD, I joined for MSc, and I go for PhD and I do this. I am not discouraging or encouraging. It's all that you must identify your capabilities and you must have goals to reach your ideas. So accordingly, you work sincerely. But anything very important thing is you must have in your life discipline, sincerity, and commitment. So these three important words that you remember all the time, and then you work accordingly with some motive. Goal అనేది చాలా important. I must become an engineer. I must become, say, a politician. I must become, say, for example, a good scientist. I must become an engineer. I must become a good teacher. ముందే డిసైడ్ చేసుకొని అకార్డింగ్గా మీ దేంట్లో కేపబిలిటీస్ ఉంటాయి. You can become a director, you can become a scientist, you can become an engineer. No issue. But మీ మెదడు మొదలు పెట్టాలి. This is very, very important. So, I wish you good luck in all your endeavors, future endeavors, and all the rest. Thank you for the invitation.
Thank you very much for the practical and
ఫోన్ చేసి అన్ని కల్చరల్ యాక్టివిటీ ఉంది కదా
మ్యామ్ లైవ్ కట్ అయిపోతుంది ఏం కాదమ్మా.
టోర్నమెంట్
Student presentation, Chandralekha, 30
Good morning, everyone, respected dignitaries and lecturers. I am Sri Chandralekha. I am studying BSc Physics third year in this college. Today we are discussing about physics, space, and rockets, and evolution of rockets, and how physics are applicable, and many things. Today I am going to speak about the evolution of rocket science. Rocket science has evolved over many centuries. The earliest rockets were invented in China around the 13th century and were mainly used in wars and celebrations in that time. At the later 20th century, scientists developed the principles of modern rockets using a better fuels and engines. Their work led to the launch of satellites, human space flights. In first time, today the advanced rockets are used for space exploration, communication, weather forecasting, scientific research, and satellites. Rockets have made space travel more affordable and opened new possibilities for future missions to the moon and Mars. Thank you for
Thank you, ma'am. Next, thanks station to our chief guest.
పోండి. ఓకే. క్లాప్స్ కొట్టండి. దగ్గర ఉంది. ఊరినాడు ఎందుకు మిమ్మల్ని కవర్ చేస్తా.
Okay. Are you okay now?
Okay, sir.
Shall we start?
Sure, sir.
Maybe I will just give you the links. Don't
Okay.
worry that I will not go into the mathematical equations and the statements and other things. I just give you very briefly, just to ignite you that what space exploration is. Okay? At the outset, let me thank the organizers of the physics department, in particular your health department and your teachers, Jayesh and Madam, and my own student, PhD student, actually Sanjay, and to your principal. And it's also honor for me that I'm just retiring in another 15 days, 31st of this month. And they just asked me to just give a lecture. Okay, I thought, okay, maybe I can share my ideas in this particular direction. And in maybe one day, with my busy schedule, I would able to collect some of the major issues of the space, and then I present you and share with you. So what I wanted to discuss here is the space science and technology. What are our space programs and we wanted to explore it? What is the necessity here? Spending crores of rupees towards exploration. And when compared to the other countries, then how our India is progressing in this particular way. So maybe I'll touch upon. And maybe very briefly, some of the important gadgets which are being used in the satellites. Maybe I will just present you how they will appear at the micro level, maybe using nanotechnology. I'll just show you some of the slides there. Okay. So this is the space technology. So maybe you all know maybe one of the missile man and the eminent scientists of our country, Dr. and Honorable APJ Kalam, Abdul Pakir Jalaluddin Abdul Kalam, a person who came from a very remote village and money used to distribute the papers. The paper boy raised from very low level, and then reached to a very high position. It's the first citizen of the country, the president of India. And having no other background, family background, to influence politically or scientifically or to support him also. That's why I just put his photo here and made a significant mark in developing the science in our country. Actually, in the beginning, people like Satish Dhawan, Homi Baba, and Raman, Sasi Raman, Chandrasekhar, these These are the people, Rana, Bose, Rabindranath Bose, these people who contributed for the science in India. And before 1950, you just observe 1960, our country is almost parallel with the other scientists, or sometimes more. And we could not catch the track in ultimately. That's why now we are buying the technology. So let us concentrate on this next slide. This space exploration. ఇది ఎవరైనా ఇక్కడ నాకు ఒక సెంటర్ ఉంది, ఎవరైనా వెళ్ళినారా స్పేస్ సెంటర్కి? చూసారా ఎవరన్నా?
సైన్స్ సెంటర్
ఎందుకంటే వాళ్ళకి వీటిలో ఒక రోజు ఉంది వాళ్ళకి. సో స్టూడెంట్స్ కెన్ గో అండ్ దెన్ సీ. యాక్చువల్గా అక్కడ పోయి చూస్తే కానీ మీకు ఆ లాంచింగ్ వెహికల్ ఎలా ఉంటుంది, రాకెట్ లాంచింగ్ వెహికల్ ఎలా ఉంటుంది, పిఎస్ఎల్వి మీరు ఎస్ఎల్వి అని చూడొచ్చు మీరు యాక్చువల్గా. అండ్ దే లాబొరేటరీస్ ఆల్సో హౌ దే ఆర్ అసెంబ్లింగ్ ది కంటెస్ట్. So most of the assembly work in ISRO will be done in Bangalore, ISRO center. So where I visited many times. And this is space exploration. Next. Yes. In this, let us see, we will observe what is space exploration, why we need to explore the space, what is the history and the future of the space, and India's work in space very briefly, and why space exploration is more important, and in space exploration what are the contributions. Then I will conclude briefly. Okay. Now you see, when we try to understand the Big Bang theory, actually the complete matter has been pressed and then it exploded and distributed like, say, for example, many families. So one such family is our solar family. So in the solar family, all the other planets are evolving, and we are at one planet Earth. And thinking that we have a big world here, and we are living, and we have comfortable environment and for the living. So now people thought that charity now to explore this space. When I show you the next slide, how we just explore it, and how many ways that we can just move. Either we have to travel or without traveling also we can do. But what extent that we can just do. All these things we will try to do. Nothing of the power.
కనుక్కొనుకెళ్ళారు
So maybe I just discuss. Okay, I think it is audible for you also at the end. బాలభారతం అని ఒక సినిమా వచ్చింది. నేను చిన్న అంత మొత్తం చిన్న పిల్లలతో మహాభారతం నడిపిస్తారు. అందులో ఒక సాంగ్ టీము పిల్లవాడు అతను ఏంటంటే కనుక ఇందులో కలిసిపోయి దేవాలయం చెప్పేసి బయట. అప్పుడు ఆ పాట మానవుడే మహనీయుడు, ఇంద్రలోకమైన దేవేంద్రలోకమైన ఎక్కడికైనా పోగలడు, ఏమైనా సాధించగలడని ఆ పాట ఒక జిజ్ఞాస, మానవునికి ఒక జిజ్ఞాస. ఆ జిజ్ఞాస ఉంది కాబట్టి మన సరౌండింగ్స్లో తను ఎలా ఉన్నాను, నాకేం కావాలి, కాబట్టి నేనేం ఇన్వెంట్ చేయాలి అని ట్రై చేస్తూ పోయినాడు. మనం అంతా కోతి నుంచి పుట్టాం. పుట్టిన తర్వాత ఏంటంటే మెడల్ నాలెడ్జ్ పట్టించి అవసరం లేని లోకల్ అతని ఎడిపోయింది. చిన్నప్పటి నుంచి మీరు జస్ట్ అబ్జర్వ్ చేస్తే సైన్స్ టెక్నాలజీ ఎట్లా డెవలప్ అయింది. ఫస్ట్ మానవుడు అసలు గృహం అనేది ఉండేది కాదు, గుహల్లో నిర్వహించాము. ఆ చలికి దానికోసం అని చెప్పేసి మనకంటూ ఒక సొంత గృహం కట్టుకుంటే బాగుంటుంది. తర్వాత కప్పుడు దానికి బట్టలు కావాలి కాబట్టి ఫస్ట్ నాలుగుతో పాయింట్ దారం ఎట్లా వస్తుంది, దాని నుంచి మళ్ళీ బట్టలు లీవింగ్ ఎట్లా జరిగింది.
On the other side, people try to think of the medication. So earlier, only one science, which includes engineering also, medicine also, everything of the science. Depending upon the necessary, necessities, what are the essential others, all the divided is
కానీ స్పెషల్టీ రియాబిలిటీ చెప్పేసినారు సార్ మైనర్కి ఎవరికైనా డౌట్స్ ఉంటే ఒకవేళ తర్వాత అయినా కరెంట్ వచ్చిన తర్వాత అయినా సరే సార్ స్పీచ్ అయిపోయిన తర్వాత అయినా క్వశ్చనేర్ ఉంటుందమ్మా, మీకు ఎలాంటి డౌట్స్ ఉన్నా కూడా సార్ని అడగండి. వచ్చింది
Now you see? Okay. Theory of perturbation అని క్వాంటం మెకానిక్స్ లో ఒక పెద్ద చాప్టర్ ఉంది. క్వాంటం మెకానిక్స్. ఇప్పుడు నేను మీ పాఠం చెప్తున్నాను, మీరు ఒకటి మాట్లాడుతున్నాను. ఫర్ ఎగ్జాంపుల్ ఎవరో ఒకరిద్దరు మాట్లాడుతున్నారు. The perturbation that part which disturbs me when I am teaching here. అదే విధంగా lattice లో for example, you have number of atoms and you are setting say for example very minute current say for example like 1 ampere something like that. And each atom vibrates in its mean position, okay, in its mean position. This is nothing an abstraction for the flow of the you start to resist. Suppose you will pull it to say for example the freezing temperature say for example less than 4 K, 2 K something like that. Kelvin, 2 Kelvin. Then the material will become superconductor. This without any resistance, R is equal to 0, the current will flow. Now you see when there is a small vibration even, that means you get a small signal here. Because when the electron moves, it's associated with wave character. And these waves superimpose. And this superimposing point of superposition. These waves superposition occur. For example, you might just take it as a 1. And then the on state, this is the on state and off state. For example, if the two waves of the same superimpose on one another, we do maximum. That is, say for example, let us assume L1. And if you say for example, if the two waves superimpose in a different way, so then you will get minimum because this is equal of superposition. This is known as the numerical theorem. This is the first that we have to see. That means you are making a binary computer or a quantum computer with very high speed and high memory. This is the quantum technology. So the information and very small things are there. But this is now you can do. That's why your supercomputer, the quantum computer, what people are now talking about this era. Because that chip has to be maintained at a temperature of 4 less than 4. That's the most difficult thing of And then you must live in a specified time and you must be able to come back also. Going and coming back, not like a simple thought that I can just go travel here and then go back again. But you see, the environmental conditions are completely different. And the food habits that you might have seen in when Sunita reviewed some photograph, even drinking water against the gravity is very, very difficult. How to drink water? And how much technology might have been developed to take the food in terms of the tablets so that they will just work inside and then. And they will sustain for the radiation. Water is water. And you know the temperature outside, very hot temperature. Summer will be 100% Tuesday, so we have a lot of temperature difference. And we are struggling even of that. And the temperature is 100. History says that. So, in October 1957, the Soviet Union launched the first Sputnik, we all know that one, into a low Earth orbit, so it was called the space age. It was the start of the space age. So you can see this is Sputnik here. So in response, so this one side the Soviet Union, and on the other side the United States of America. Immediately in January 31st, 1958, maybe after 1 year, so they are also started and they used this Explorer 1 and they sent as a space taker in the atmosphere. Yes, next one. So the first life. So first they sent without any human being or living creatures. And after that, the Sputnik 2 had a passenger for its journey, which is called like a name of a dog here, you can see here. They have sent it. So, and they have created the environment inside the satellite and then they send it to the atmosphere. First time. And just 2 weeks after successful launching of the Sputnik 1, Soviet Union also again they sent one more, it's like Sputnik 2. Yes, next. So first human in space using Gagarin, we all know. It's on April 12, 1961, the Russian astronaut Yuri Gagarin became the first human in the space orbiting the Earth once. So you can see Gagarin traveled in the spacecraft named this name of the vehicle is here, words of one. VOSTOK, words of one. Here is the Yuri Gagarin. Yes. So the first man on the moon. So you can able to see here in 1969, Neil Armstrong became the first man to walk on the moon. How do you see the transformation? How it has been in one decade? Started in 1960, sending a vehicle, and slowly now they have created the environment and the biological environment for them inside. Maybe very difficult to prepare for such hostile conditions to travel in space. It's not as simple as that. And the space shuttle is named as Apollo 11. Next one. So this is the space technology. So how you can just see that very too much traffic now. So many countries are sending these things. Yes, next one. And you know Shara, she's a lady from India. You all know that they traveled and stayed for months together and came back together this time. And one more thing is that it has gone and they have seen. And you see, her health has been deteriorated very much because of the radiation efforts. But still, she is sustained, and we pray with God that she will have 30 years at least. So that I'm a lady, but the failure is there. The courage of the participants, that was the but still she was able to achieve. Yes. So for all the lady community, I do salute here. Not only for Sulika Williams and the other two she has gone independently, then operated particular place and they just try and then get to see how much they have done that she is working for the country. This is very important. Yes, next one. So curiosity, you can see the curiosity, Mars Science Laboratory. So first they tried for the moon and then they wanted to go see for the other planets also. So curiosity, the Mars Science Laboratory, so they have established, and it is a car-sized rover explorer. You can see later on the Mars. So it studies the planet's geography and assess whether it is ever had conditions suitable for the life. So, is there any possibility for, say, there in the Mars? So, there is a possibility people are anticipating, but we don't know so far. The results are not very encouraging. But you see, the Curiosity rover is controlled from NASA. It's a jet propellant laboratory in California, where the scientists are working controlling events. Obviously, two important things here. So one is how beautifully that with the remote controlling that they are controlling the space, the vehicle, and at the same time, whatever the information that they have gathered from there, take extra various questions. For example, if you want to see the now, you can also use the abstractions in the condition. Whatever you choose on the fiber, you can see a better picture of the so like that, if you want to see the space here, so if you go to moon and then look at there, from there, it is not sufficient, so people have gone to the Mars, and then they have explored the Mars and as well as the universe also. They send the, from there, the distance becomes no matter. So if you set a beam here, you all know that the light will take 8 minutes to reach from the sun to the earth. That you can calculate the velocity of the light will not be for per second. So we can able to see for 8 minutes so how much distance that we travel, that is calculated there. So Now these are very important to control the gadgets. Say from there you can put an air beam towards the sun and then see and the reflected beam that means without any obstruction that you can see that you get a better signal and you can see on the surface of the sun what is the temperature, then how the nuclear fusion and diffusion reactions are taking place on the sun, that how is that you can just do. Similarly, for the other planets, maybe other, say for example, families of the planets, we can see and we can explore many things. If there is such other families also available. And you know the dark matter development and all these things are explored, using these things. Yes. Now, so this is the status beginning, and now you see India work in space. So April 1975, India launched first Aryabhata. The India launched Aryabhata from Russian rocket using Cosmos 3 launch vehicle. This next one. So India's first satellites on the moon, you know, Chandrayaan-1 was India's first lunar probe. It was launched by the Indian Space Research Organization in 2008. Yes, next one. So India's Mars orbit mission is the Mars orbit mission, so MOM, that what people say, also called as Mangalyaan, was first India's biggest success in the space. So we reached Agrawal Mangakuda site, the size and technology. We have the capability of launching. So India is the first Asian nation to reach Mars orbit and the first nation in the world to do so in its first attempt itself. And we are to abiding that they made this venture. Yes, next one. So does the state really matter? Is it necessary to explore? Maybe I will put the pros and cons maybe on other side. You can see 1990, US spent about, say for example, $100 billion Apollo moon program. The money to కావాలంటే మనము a year of health care for 1,65,000 people. And we can give electricity, say for example, 8,300 people in the year. And say for example, building homes కావాలంటే 2,000 housing countries. ఎందుకు ఇంకా స్పెండ్ చేస్తున్నారు అనవసరంగా అది 1%. ఒక బాధలు ఆ డబ్బులు
దివ్య వచ్చింది నా పక్కకు రండి
No, because we have a lot of other issues
Yeah.
to solve on there. I just
Pepper Ramman.
because it's not simple thing. That means to make Mangalyaan, if I remember, I think we spent about maybe something like 1,000 crores. It's not that so simple. And space exploration is always a big investment. Normally, movement of satellite commission normally it costs about 300 to 500 crores. Not that simple. And money should be used for the development just for the even use as well. Next slide. That we see, maybe development is also essential. On the other side, it's also essential to see or to observe the complete universe. So, which we can able to see here now, the communications in the development by Karnam, it's all because of the satellites which are orbiting. So you send a signal, now you know how just calling to USA in a fraction of a minute. How it is possible now? Now your signal, your voice signal will be converted into the sound signal will be converted as electric signal, and then from there to its microwave, it goes to the antenna of the Tirupati, and then from this antenna to satellite, and then from satellite to your USA, the particular place antenna, and then from there to your mobile, and the microwave is converted into electrical waves, and then electrical waves converted to the voice, and then you will receive the voice. Just see, such a big process, you are doing it in a fraction of a second. But you never think, it's more easy for me that I can do. But how it is possible here? It is only possible because we have our satellites which are developing on the moon, and then it is possible for the communication that this particular band of frequency that it just takes and then it emits. Otherwise, it is not possible to have such a communication. And our satellites lived out the communication later, 1860s. When I just worked in Madam Julie University in France in those days, only normal homes. There, which is call which is there after some time that just that years back. Then I said now that I could not Uttara now it is everything is now. Yes. It's a very important. Sorry, total bags, right? And now you see, so tell me, this is one side is communication, another side is the information channels internet, and the connectivity all parts of the country. So you can see how you can right over Google level is search. And what the YouTube level is search. అవునా లేదా ఈరోజు చికెన్ చేయాలి ఒకటి చేయాలా లేదా చిల్లీ చేయాలా గవర్నమెంట్ ఏదైనా సమస్య లేదు సో మొత్తం ఎవరైతే తీసుకుంటుంది దాన్ని నేను చేస్తాను బట్ అఫ్ కోర్స్ మీరు ప్రాక్టీస్ చేయకుండా చూపిస్తే కనుక మీకు రాబోయే ఎఫెక్ట్స్ చాలా అండ్ అడ్వాంటేజ్ ఆఫ్ స్పేస్ ఎక్స్ప్లోరేషన్ ఇప్పుడు ఏం ప్రాబ్లమ్స్ వస్తాయి మిమ్మల్ని పంపించాలన్నప్పుడు ఇప్పుడు ఆ ఎన్విరాన్మెంట్ మెయింటైన్ చేయగలరా ఇప్పుడు హార్ట్ కొట్టుకోవడానికి ఆ పర్టికులర్ ప్లేస్ artificial buildings and artificial heart also because of they thought that how to survive the human kind that they are traveling in very high standards. And the program of the heart pacemakers in 1970 using Maka satellite. So they just also get side by side these pacemakers. So after development, yes. And the advantage here, image processing used in scanners or MRI technology in hospitals, the worldwide team of the technology developers and computers improve and their memory and the speed increase many times now. And all the calculations are being programmed. So they have started with the joystick, but now nobody is using the joystick. That's done. And in those days, it's very essential to control with the joystick, the momentum, the three-dimensional space. But still, people are the joystick is being controlled by the computer now. Even for example, you are scanning electron microscope, where you are putting your sample and then recording. And it is recording, say, for example, at 1 nanometer resolution, for example. It's all very essential that it has to be controlled. The beam has to be scanned and it is in a three-dimensional space, which is very essential. So, such things are being developed by seeing that how we can just make such gadgets for this space. So, I will normally use just there. So, you can see drains, mining trucks, and now you see the construction of a building now. It became very simple now because they have developed many technologies now. Now it uses the design and then it artificially builds the building all machines only. Now it is becoming more very easy rather than waiting for say constructing big building. Just do in place, say for example, one day you want you can just house building. And you see, because they cannot take the normal let's say not possible because of the gravity issues there in how you just go to the mouth and then you take. So special goods are to be developed. Microgravity semiconductor materials that can produce the chips as much as 1,000 times more powerful than any other material. And you can see the pharmaceuticals produced in the space zero gravity and they have the purity of higher than the produced on the Earth. And they have the element. So you can also see the element helium-3 that has been discovered in this exploration on the moon and could power the world at least 1,000 years. Yes. And you see the asteroid missions to understand the formation of the solar system and how water and organic materials came into that. So that they try to black calculations and find the way to reduce the possibility of nuclear impact on the Earth and the exploration possibility of mining and the supply of and you can see that one of minerals then you can see what are
మేము
the,
ఎడిట్ చేసుకుంటాం
ఇదే పెట్టేయచ్చు కదా
ఇదే పెట్టచ్చు
యూట్యూబ్ ఛానల్
and people try to, because here in this simple satellite that you can see, there are many things. So you will have energy dispersive X-ray machine to see the element in this one, and you will have the and then see these vibrations, and from these vibrations, bridging and active parts can be calculated what material is available, what is suppressed, that can be done. Okay, such many things that they are just concerned. There are any new elements other than the elements that part they have discovered. So all these things can be done. Okay. So addressing global challenges, monitoring global warming is one of the things. How you see, actually June 10 start here. Because of the effect that we are suffering, and the temperatures are more than 40 degrees now, and it's very hard. Then what is happening to global warming? Then how to protect it? So all these things can be understood. So developing capabilities of global protection and the space debris removal. So now we can very quickly. So there is also another point that we are managing. And building mutual trust and understanding among the nations and the climatic change. Next one. And life in space. People try to search for the life in space. Are we alone or any other existing in the space is another thing. So in this, people try to explore some of the planets that which are unknown here that they have discovered. These are all. These are light years. Light years. And maybe I will just give you the India scheme, how we can do that they are just, yes, next one. The momentum and the growth, you see, decades of engineering time dedicated to establish the knowledge and capability, launching several space, often is part of the space, so that people try to adopt it, and then they try to send the vehicles between 1962 to 2001. Yes. Next one. I give this here. You can see 1962, and then between 65 and 70, so institutional genesis that have been made, establishment of space science and technology that are here. So in 1968, April 15, and then after that, people developed satellite launching vehicles.
Didi,
And after that,
మ్యామ్ రాధాకృష్ణ సార్ ఫోన్ చేస్తాను రాధాకృష్ణ సార్ నెంబర్ ఉందా మ్యామ్ ముందంటే మ్యామ్
And these space pioneers in the era 2, that's the era between 1960 and 2012, and this is 2013 and now you can see 2013 is the Mars upgrade mission here, Mangalyaan, with the solar satellite launching vehicle C-25, and they are just loaded and then first time to so. And the second is 2017 launching here. Demonstrate high density urban development and putting about 104 satellites into space in 2017. And Chandrayaan 2019, Chandrayaan 2 successfully launched here. That is making so the high resolution images that are there Mars. And Chandrayaan 3 in 2023, Aditya L1, and you all know that it has been launched here. And you see now it's going on evacuation, and now we are now going for from the NASA to see if to send out people also to space. So this is a sequence starting from 1962 to till 25 and now this is going on. one side is assembly.
మేడం చందన ఏదో అడుగుతుందంట
Using the gadgets made from India only that they are trying, but still the primary engines that they are importing from India. Of course, the power also, it requires a lot of power. So they use the solar cells and they use batteries also. And you know, your mobile, I give one example here, your mobile, if you see, for example, if your mobile is 100 grams, in 100 grams, 30 grams, 40 grams weight is because of your battery. Because of your battery. Now you see, you could use the same thing, it becomes very, very difficult for the satellites to understand. That means the power is 10 kVA and your battery is 10 kVA. So, అది దగ్గర దగ్గర 200 kg 300 kg 200 kg plus satellite పంపిస్తే మొత్తం 200 kg అయినప్పుడు battery ఏం జరుగుతుంది? It's very very difficult. So that's why solar cells are being used. But solar cells తిరుగుతుంటారు కొన్ని ఆర్బిట్లో. ఫర్ ఎగ్జాంపుల్ ఇప్పుడు ఈ సైడ్ సన్ ఉంటుంది, సో సోలార్ ఎనర్జీ వస్తుంది, స్క్వేర్ కన్వర్ట్. బట్ ఫర్ ఎగ్జాంపుల్ దట్ సైడ్ గెట్ ఏం జరుగుతుంది? సో సన్ ఎనర్జీ you have to store the energy. So you need battery component, half of the battery to store the energy. So for that, always the solar cells are to be integrated with the battery component. So that is very essential. So people now try to establish this as a business of less than about 1/10 of your hair diameter. You know your hair diameter? మీ వెంట్రుక ఎంత diameter ఉంది చెప్పండి. అంటే మీ విధానం తెలియదు. నార్మల్లీ 18 microns to 120 microns. One thick hair is 1,000 years. But it is between 80 microns to 120 microns. According to 5 micron thickness లో that is solar cells. So now the technology is going to that. And the concept of working now, people used to say, maybe when I was thinking, later to later on engineering college, I used to say, today I read electronic magazine, today there is passive devices. Active passive devices are transistors, and of course, the resistors and capacitors are inbuilt with the transistors. But now those days have gone. Now we went to the atomic level, the people are making the transistors at a single atomic level. Single electron transistors, people are nanometers, all are developed at very image atomic dimensions. At the atomic dimension. One layer of P, one layer of N, so you will have a PN diode with 2 atomic layers. See the technology how it is.
అది ఆన్ చేసి వచ్చే కొద్దిగా
Yes.
అది మిడిల్లో వీడియో ఆన్ చేస్తా.
Next one. So the future of the space technology, as India moves past 2020, so maybe 2030 that you can just make. The technology horizons focus squarely on manned operation, in space sample returns, and the permanent orbital bases. Developing high frequency and low impact autonomous radar systems underpins these ambitions. And the transition towards the reachable launch systems and the giant dual band planetary radars is another important global commercial exploration leader. Yes, next one. Now you see the universe is another side, so maybe you can make all these things maybe one by one, maybe it's not possible, but you see there are many opportunities and opportunities that you can just. Yes, next one. And you see the ISRO continuous, so I just kept here all these things here. What are the exploration that people are unveiling the universe mysteries? What are the mysteries and how we can be? You can see I just kept it everywhere here in one slide. Maybe you just see one of the black holes, you can see, and the neutron stars. You can just see what is the temperature and how it exists and how we are located. And you see going to absorbs all the electricity falling on it, then how it is possible that an object which absorbs, because only a byproduct which absorbs and also emits, emit, just absorbs only. And the technology enables you to discover say many things here. So this is all about your space exploration that I can just put it in a nutshell. Space exploration is the key to the future, and we will reap the rewards of the necessary investment of the money and the resources. And the researchers and technologists about the space exploration are very important for the humanity. Without risk, we remain in our caves, never daring to see that the immediate challenge. Now, the money we are spending on the now space program will help a long run in understanding. Despite the fact that the space exploration projects need huge amount of money and labor and also time, it cannot be totally ignored or stopped. So maybe it's always essential. So space always inspires you that from which we can learn the nature and the space. So you can inspire and always gadgets and every scientific investigations happened by just observing the features. There are many things. Yes, maybe I will show you some of the gadgets. This is about the space exploration and how the nanotechnology at nano level people are making these devices. I will just show you maybe one or two slides. Go to this one. So because this different is my topic, my specialization, where my students, about 20 students work on this business. We work on many projects, even including defense projects, also developing micro batteries and developing solar cells, supercapacitors, micro supercapacitors, and we work on sensors too, and then electromagnetic devices, power change devices. Many areas we also touched upon, but I just told you that this thin films and nanotechnology, a thin film is a very thin layer of arrangement of the atoms, whose thickness is less than that of 1 micron. But those days have gone. Now we are working at 0.1 micron or even less than 0.1 micron. That means you can see it's like 100 nanometers. We are just working at 100 nanometers each layer. So where you can able to see these are the advantages. There is some devices I will just show you. Carbon nanotube and graphene and semiconductor silicon light that's preparing gallium arsenide like devices using this thin film technology. Yes, because these things are nanomaterials enhance the performance, reliable efficiency, and will have the high performance for aerospace systems and within this way. Because here you just have 200 milligrams of silver, you can just go for about say for example 1 liter by 1 liter silver on the sheet. For example, you 1 gram gold, the gold becomes very costly now. If preparing 1 gram gold, this is what electrochemical law, your gold deposit is very thin layer of gold is deposited on the water. 1 gram is one, you will just prepare, say for example, the in the next time అది 1 gram మొత్తం ఒక extract చేస్తే సో always it covers about 1 liter by 1 liter. It will be about less than 100 grams. Yes, next one. Now you see the batteries of 3 dimensions in nature. So maybe 1 dimensional, 2 dimensional, 1 dimensional, 3 dimensional. Dimensions become very important now. You can see your anode and cathode. There are 3 dimensions and between electrolyte. So your battery which consists of 1 anode and 1 cathode, and you have the electrolyte sandwich between the anode and the cathode. So this you can see that the size is very important. The 3-dimensional nano size is totally this battery here is about 1 micron by 1 micron size. And the layers which are here I am just showing these layers are less than 1 micron. So you can just deposit 1 micron layer of cathode and 1 micron layer of electrolyte and 1 micron layer of anode. So So you will have within 2-3 micrometers to work. That means the total thickness of this battery is about 100 times less than that of your air bag. You can just recover. And just it gives you 3.5 volts to 4 volts. Of course, the current is in microamperes or in amperes. But you can integrate, you can have many numbers, you can stack like layers to enhance your characteristics. Yes. And this is a solar cell, you see, your satellite is completely in solar cell. So when it goes to the orbit, then it stretches. And it is something like 20 meters, 50 meters, 100 meters, like now you can have the solar cells, which are like max that you can just rotate and then you can just do it. So when it just goes to the orbit, then it stretches its wings like. So the thickness here is about 5 micron cells in the technology. So people will have all the different layers of wings of the satellites here. Because when you say satellite, the wings and solar panels. Next one. Now you can see some pressure sensors here. This normal and the this normal. Blasts and the Darina, you will be very safe because you can pressure sensor watches immediately when it just strikes. Then you can see very simply. You can see here the next there are sodium azide. Now when the one light flow, the reaction of sodium azide which explodes and releases fractional semiconductor reaction. The fastest reaction which is available is with the sodium azide. And because of this, so immediately the nitrogen it comes to the balloon and then balloon opens and you will use. So that balloons will be there. 6 gani, 4 gani, balloon, all of the products, the pressure sensors. Next one. This is a gas sensors. You deploy the gas filter or any other protected gases, then CO, and then nitrous oxide, ammonia, sulfur dioxide. So you can just see here, these are the different layers. Then you can see here about 1 to 2 microns, something like that. And you can measure this one. Sensors, simple sensors. Similarly, you can have IR sensors also. Iridium dioxide is an IR sensor, and it measures the temperature. So all IR sensors where there is simple yes. And you can see the smart windows here. So you have a coding here, you go ahead you coding program, then there will be some the smart windows. So it changes its color as the light passes so that we can comfortable inside the car or inside the bus. So these are called photochromic or electronic. And the light button change on electric releases change on power change. There is a possibility that maybe tomorrow the technology will be you can have on the car, you just want to know the car color changing.
Yes.
5 volts supply is the electro-going you will find red color. 4 volts supply is the blue color. And for example, 1 volt apply is the same material. You can apply for your sarees also. Maybe say for example, put it in a small battery only. With 1 volt they get goes to your saree or saree. You can change your saree to green color saree. Without changing your new saree, the same saree is different items that you can just for any functions. 2-3 functions you can attend at the same time. Without any change. So this is the first. Yes. So the instruction windows and okay. You know your cooling glasses, which controls the same only visible light it allows, and all the IR absorber and UV absorber it are so these are all the cooling glasses. So let's see whatever the color that you want to do. Yes, next one. It is now you see this became a very big business nowadays. So power up to 40 watt power will be 2 by 2, you 1 watt you will get that and you can have many designs in the EV. They're very small, 1 amp by 1 amp you can have. Next one, I'm using the different transistors. Now the gate size, you can now I'm just talking about what amp, but how people are now expecting. Yes, next one. And you see the micro car, the particular panel, you have a micro car. It's possible now. You can run. Yes, this one. Okay, is this one? Yes, you see, these are the little bit super alloys here, which are being used like grids, and then you can see here to make the turbo generators here, the turbine engines that you can just make, which can move 100 rotations per turbine. It is difficult to imagine, but still there is a possibility that you can just make. Otherwise, the turbo engine, the turbo engines of this actually. 1 liter turbo engine that you can just use to power magnetic the surface kind of the bottom, so they report with the hot bodies because they rotate very high distances, which must generate a lot of heat, so it must sustain a lot of heat and pressure. So this is something very big. Next one. So these are the recent monolayer transistors here. You can see that is only one monolayer, source and drain. So you can see the able to see that the gate is tracking layer. One monolayer. So these are all the materials that are being used by the and then we will put the minus sensors. So in our book, we published in 2017, 18, biosensors and bioelectronics, one book, and some of the other. So now there is no destiny, you can have a biocode, and you can wear the biocode, and you can see there is all the points of your body, and then you just take a biocode and put one minute in switch on and then come back, and the complete body will be scanned, and you know everything about your life. You know everything in it. You can wonder and the technology is ahead to see you like this. So this is the ultimate biocode. And there is a possibility because now the nanotechnology which came into existence in making the motors and the sensors at the nano level. You know your red blood cell, the blood load and red blood cell, the diameter of the red blood cell is 6,000 microns. 6 microns. 6 microns. Now what happens here to the adrenaline is very important. If you can make the complete robot with less than 6 microns,
low battery వచ్చేసింది మేడం low battery
and you inject it into your wheel and ask the robot to go and do heart surgery and come back. The technology is now extended to that state, that means without doing any operation of these things, you can inject it into your wheel. Your wheel size, you can just see it may be something like 1 millimeter or say for example 0.1 millimeter, something like that. But you see your device is at less than 1 micron. So this robot can go inside the body, do surgery and come back. Maybe one of you can develop this, maybe you are artificial intelligence scientist, and you see your artificial eye that you can see that because so far you can have artificial heart, you can have artificial, for example, kidney that you can have, but there is no artificial eye or your eye. I think that the over the very people probably would like now. Sir, is what that. Yes, you can see. One biosensor, for example, you see the cross section of your eye is like this, you can see here. If you can prepare And say, for example, if you can have the surface of the eye is like this. This is about 1 micron by 1 micron picture, where you are able to see all the sensors are, say, for example, it is like spherical, you can be able to see. That's why it is with the convex shape, with the semi-convex shape. That's why you can see that it takes the signal and then it gives to the brain that after seeing it, that is when you are traveling there from something there in the dream, so you immediately identify and they immediately break and then it has something later. But you see how it is happening everything, information, ethical information, and then you can see that our brain is connect and then immediately orders, for example, this is from flow, and immediately this is sense, immediately, and send the information electromagnetic to the brain, and brain immediately orders our hand to kill it. Everything is happening in a fraction of a minute. Every day you are seeing, but you are not thinking that why don't we create such a sensor for our daily life? షడ్రుచులు ఏ రుచులు చూడగానే యాభై పెట్టుకుంటానే చెప్పేస్తుంది. ఇంతవరకు మనకు ఒక అట్లా రుచి చెప్పే డివైస్ లేదు, సెన్సర్ డివైస్ లేదు. ఏదో గ్లూకోజ్ చూసి కరువుల కొండ ఏదో పెడితే రిక్వెస్ట్ పేపర్ పెట్టి మారుతుందని చెప్పారు చేసేయాలి. బట్ కరువులోనే మీరు డిఫరెంట్ టేస్ట్ మీరు ఇలాగే చూపిస్తుంది. ఇది మంచిదా కాదా, తెలియదా, బాగుందా, ఎవరిథింగ్ చెప్తుంది. మన స్కిన్ అండ్ సెన్సర్ థర్మల్ సెన్సర్ కదా. సో there are many challenges before us to solve for our existence. And those space explorations లో ఇవన్నీ మైండ్లో పెట్టుకొని వాటి ప్రిపేర్డ్ many gadgets for the astronauts. అందువల్లనే మన సైంటిఫిక్గా ఇంకా డెవలప్ అయింది. సో our space exploration is a part of scientific innovations. Okay, so if we are successful in innovating many gadgets, yes, we can do. For example, in space travel, if you were able to say build a polar launch vehicle in such a fashion that it reaches moon in 1 minute, going with the fastness of our, say, for example, our light speed, then every day you can go in the morning, go to the moon, and then walk and then come back to Earth. Again, you are place. For example, tomorrow there is one planet where there is a mankind existing, and you can go in a car and then come back. అందులో మనమే చేయాలని ఆలోచిస్తాం. కాబట్టి ప్రతి ఒక్క విషయంలోనూ మీరు చదివేటప్పుడు వాడు ఎందుకు చెప్పాడు కానీ సినిమాలో మోహన్ గారు ఎందుకు ఏమిటి ఎలా, దిస్ ఈజ్ వెరీ వెరీ ఎక్సెన్షియల్. అది వచ్చినప్పుడు మాత్రమే ఎప్పుడు జరిగితే అబ్దుల్ కలాం సేస్, if there is a problem, don't worry about the problem, but you must see that you must become the factor of the problem and solve the problem. This is very important. Okay, so finally I urge all the people, maybe you can have the very milestones of your journey, and then you can see that everything in a innovative mode, and create yourself and stand yourself that you are in. And really good things for our life. Okay, I wish you all the best. Thank you.
Clap.
So I try to push the idea from the space, and later we devices mentioned micro electromechanical system and nano electromechanical system. And here I put in two figures. This is the airgun where you can take your atom, move your atom, put it in the right path. That is wonderful. For example, we forgot the collision in the atom and you can write it. This is one here with the 24 copper atoms that they have generated on this. But the diameter of above 100 nanometers. So all atoms to here, here. So such technology is being available now, and the essential for us to develop. Thank you so much. taken a lot of time.
Okay.
నాన్న ఎలా ఉంది ఆ ప్రోగ్రామ్? చాలా బాగా చెప్పారు కదా, మీరు చాలా బాగా విన్నారని అనిపిస్తుంది. మరి బాగా వింటే క్వశ్చన్స్ కదా, రెడీ ఉన్నారా క్వశ్చన్స్ అడగడానికి? ఓకే, 1 by 1 క్వశ్చన్స్ అడగండమ్మా. సార్ విత్ యువర్ కైండ్ పర్మిషన్. ఓకే, ఒక్కొక్కరుగా క్వశ్చన్స్ అడగండి.
What are the essential skills for future astronauts? What are the essential skills for future astronauts?
If you want to become an astronomer, what are the skills that you require? First point is you must have a physical fitness. First point is physical fitness. It's very, very important. ఎందుకంటే అది చాలా మందికి లేదు. ఇప్పుడు నేను మీరు గమనిస్తే మీ క్లాస్లో అందులో కనుక ఎంతమంది రోజు మార్నింగ్ చేసిన ఎక్సర్సైజ్ చేసేదాన్ని చూద్దాం. బాడీ అంటే స్పోర్ట్స్ మ్యాన్ ఎంతమంది స్పోర్ట్స్ చేయక్కర్లేదు, మన ఇంట్లో కూడా ఎవరైతే యోగా చేయొచ్చు, ఎక్సర్సైజ్ చేయొచ్చు, మన బాడీని ఫిట్గా పెట్టాలి. ఎప్పుడు మన బాడీ బాడీ ఫిట్ గా ఉంటుందో అప్పుడు ఆటోమేటిక్ గా మీకు ఏంటంటే కనుక ఏదైనా చేయాలని యాక్టివ్గా ఉంటారు. క్లాస్ కూడా యాక్టివ్గా పెట్టారు. లేకపోతే మీరు కొంచెం వీక్గా ఉన్నారు, క్లాస్ వచ్చి నిద్రపోతున్నారు. సో ఫస్ట్ ఫిట్నెస్ కావాలి. నెంబర్ 2, యూ నీడ్ టెక్నికల్ స్కిల్స్ టు లెర్న్. అంటే సంథింగ్ లైక్ సే ఫర్ ఎగ్జాంపుల్ యూ నీడ్ ఎలక్ట్రానిక్ బ్యాక్గ్రౌండ్ ఆర్ కంప్యూటర్ బ్యాక్గ్రౌండ్. Because this is very essential in the beginning that to understand the gadgets and how to function them is very important. So courses like space technology might have online courses ఉన్నాయి, and at the same time economical పైన ఉన్నాయి. MTech ఉంది, తర్వాత BTech ఉంది, space technology పైన, తర్వాత చేస్తే aeronautical engineering పైన ఉంది. సో ఇది కంపల్సరీగా ఒక బేసిక్ డిగ్రీ ఉండాలి. Ramada, you can do some diplomas to enhance your knowledge, to maintain the gadget. కొంత ఫిజిక్స్ కావాలి, ఎలక్ట్రానిక్స్ కావాలి, తర్వాత మెకానికల్ కావాలి, అన్ని కావాలి. ఎక్కువ తర్వాత then you can join as a scientist in any, say for example, ISRO organization. Then probably there is a possibility that you can become an astronaut. Okay. సో అందరూ అసలు కావాలనే స్థితి లేదు. వాడు ఎందుకంటే కదా మళ్ళీ ఫిజికల్ ఫిట్నెస్ చూసి ఎవరో 1,00,000 మందిలో 2,000 కోట్ల మందిలో ఒకరిని తీసుకుంటారు. ఇట్స్ వెరీ గ్రేట్ థింగ్ ఏమంటే వీ హ్యావ్ నేషనల్ ల్యాబొరేటరీస్ లైక్ DRDO. There are about 26 DRDO national laboratories, and ISRO laboratories there are about some 16 laboratories throughout the country. అంటే ఒక్కొక్కటి ఒక ల్యాబ్ డెవలప్ చేస్తాం. సో ఏంటంటే కనుక ఒక సోలార్ సెల్ చేస్తే కనుక, ఒక సెన్సర్స్ చేస్తే కనుక, ఒక అసెంబ్లీ చేస్తే అట్లా ఉంటుంది. సో కాబట్టి మీరు ఏదో ఒక సెంటర్లో మీరు జాబ్ రావాలి అంటే కనుక నేను MSc ఫిజిక్స్ మ్యాథమెటిక్స్ ఫస్ట్ క్లాస్ ఉండాలి కంపల్సరీగా, ఆర్ BTech ఫస్ట్ క్లాస్ ఉండాలి, లేదా ఎనీ గ్రాడ్యుయేషన్ ఫస్ట్ క్లాస్ ఉండాలి. అప్పుడే మీరు ఎంటర్ యాజ్ సైంటిస్ట్కి అడ్వర్టైజ్మెంట్ మామూలుగా వస్తుంది. అట్లా తర్వాత బాగా న్యూక్లియర్ సైన్స్ సెంటర్కి వాళ్ళు బాబా అటామిక్ సెంటర్లో దేర్ ఆర్ మెనీ ప్రోగ్రామ్స్. వాళ్ళ కూడా చాలా సెంటర్లు ఉంటాయి. అది నార్మల్గా ఏమంటారంటే కనుక నేషనల్ ఎనర్జీ మిషన్ అంటాము. సో దాంట్లో మీకు చాలా ప్రోగ్రామ్స్ ఉన్నాయి. అక్కడ మీరు న్యూక్లియర్ ఎనర్జీ రియాక్షన్స్ పైన, తర్వాత అనాలిసిస్ పైన చాలా కోర్స్ ఉంటాయి. దాంట్లో అకాడమిక్ కన్సల్టెంట్స్ కోర్స్ కానీ, తర్వాత టెక్నికల్ అసిస్టెంట్ కోర్స్ కానీ, సైంటిస్ట్ EF అక్కడ వెళ్ళచ్చు. So, these possibilities are only on the government side. But if you are a science graduate and having zeal and interest in doing research work, okay? మీరు అక్కడ చేరిన తర్వాత ఓకే గ్రాడ్యుయేషన్ కూడా చేరచ్చు, సైంటిస్ట్ బీగానో లేదా టెక్నికల్ అసిస్టెంట్ సీగానో చేరచ్చు. చేరిన తర్వాత కూడా మీరు ప్రాబ్లీ ప్రొవిజన్ ఫర్ ఎగ్జాంపుల్ బాబాడానికి సందర్భంలో అయితే కదా వాళ్ళు డిఏ ఫర్ కొలాబరేషన్తో వాళ్ళ యూనివర్సిటీ సపరేట్గా ఉంది, మీరు పోస్ట్ గ్రాడ్యుయేషన్ చేయొచ్చు, పిహెచ్డీ కూడా చేయొచ్చు. సో మీరు సబ్జెక్ట్ నేర్చుకోవడం మీరు ఎంత నేర్చుకుంటారో దాంట్లో అట్లా ఉంటుంది. ఇప్పుడు మన సింపుల్గా మా యూనివర్సిటీలో లాస్ట్ చేసిన ఎంఎస్సీ పిల్లలు ఇద్దరు ముగ్గురు వాళ్ళు ఎవెంట్ ఫర్ ఐఐటి ఫర్ డూయింగ్ పిహెచ్డీ ప్రోగ్రామ్స్. సో కాబట్టి బయట కంట్రీలో ఇద్దరు ట్రై చేస్తారు. సో దే మే గో ఫర్ పిహెచ్డీ ప్రోగ్రామ్స్. సో ఇవన్నీ మీరు చేయగలిగితే దెన్ you must have a
Good afternoon, sir. Recently, we have taken
one of the best profession is teaching profession. All scientists, all engineers, all political people, all administrators are the students of a teacher. And teacher can only mentor the student. One of the only profession, best profession I can say is the teaching profession. So many batches of the students can get the thing, and you can impart knowledge to the students, and then from there they can become a good profession. But only thing is, you must have a skill to teach. How to teach I must mentor the student. I must see that the last students also understand what I am just saying. This is very
future generation
graduation and with BE. At school level, I think. Then the family become junior college lecturer, PG is professor. If you want to become university professor, PhD is essential. So you can go step by step. So for example, non-education students too, for example, there are many students, they might go in engineering college, maths, chemistry, people are now thinking to open engineering these courses in engineering colleges also. Under 80s, and the open చేశారు. Quantum technology, semiconductor technology, so now you can take any course, and then you can that can be very useful. You can become an engineer.
పోతాయి అది కిందనే వచ్చి అడిగి
Good afternoon, sir. It seems to be a man of knowledge and experience in many vast areas. So I don't say that I have only my hand.
This is not charging.
Sir, but you have...
Charging, this is
Sir, okay, fine.
charging.
Sir, my first
Charging
is there any fine difference between the earth and the space? Or decrease?
Yes, very good. When the human mechanics was developed, I said in the beginning itself, they are taken into consideration. Mass and the position. And never when Einstein proposed the special theory of relativity, there is a fine dilation. For example, if two twins, that is twin paradox, that probably might have studied in your graduation chapter, so these are 5 years ago. example, one at the same time. One has been kept in a satellite and immediately is traveling, say, for example, in space. And the space travel is when it becomes, say, for example, approaching the velocity of the light, say, for example, of the, then people are able to see the time will completely changes. Maybe I can write the equation also. So it is P prime, for example, one frame of reference, say for example, if the satellite is mass, and another satellite another is for ground gravity. So this gives you
సార్ మోస్ట్ లైక్ కొట్టినారా
that is the time
నేను చేసి
in the frame of reference of the mass. P prime is equal to T minus V by C square into X divided by square root of 1 minus X square by 6. This is the formula. P prime is the time measured by the observer from the Mars, for example, and small t here is the time measured by the observer on the ground of any instance. For example, a solar figure, for example, particular time you are measuring between two shots. Then the solar based on you are now observing the two. Now what happens here is, as the speed is increasing here, the velocity of the second frame of reference related to the first frame of reference is approaching to the velocity of the light, then you can see lot of time variation. మనకు వేదాల్లో చాలా క్లియర్గా చెప్పున్నారు. మీరు అక్కడ ఇక్కడ ఒక రోజు అక్కడ వచ్చేసిందే అక్కడ టైం అక్కడ many and ఇక్కడ many years is equal to 1 hour there. ఇప్పుడు మనకు ఈ ముక్కోటి ఏకాదశి చేసేదానికి ఒక కారణం ఉంది అక్కడ, అది మీకు తెలుసో తెలియదు. ఇట్స్ వెరీ ఇంపార్టెంట్ టు నో దట్ హాఫ్ పీరియడ్ 2 టైమ్స్ వచ్చింది మన లాస్ట్ టైం. సో ఇక్కడ ఏంటంటే వాళ్ళు వేదాలు చెప్పండి ఓన్లీ దిస్ సంబడి but there is certain variation of the time. For example, ఇప్పుడు 1 million light years distance లో ఉండే ఒక ఆబ్జెక్ట్ కి ఇక్కడ ఉండే ఆబ్జెక్ట్ ఫర్ ఎగ్జాంపుల్ ఇప్పుడు ట్రావెలింగ్ విత్ సే ఫర్ ఎగ్జాంపుల్ స్పీడ్ ఆఫ్ సే ఫర్ ఎగ్జాంపుల్ అబౌట్ 8 meters per second, that is approaching to the light speed, then you can see lot of variations. ఒక కింద ఇక్కడ దీంట్లో ఫీల్డ్ ప్యారాడాక్స్ మీరు ఒకసారి కూర్చున్న థింగ్స్ ఒకటి సాటిలైట్లో పంపిస్తుంటారు రిలేటివ్ టు ఎర్త్ ఈజ్ మూవింగ్ ఫర్ ఎగ్జాంపుల్. మీరు ఒక మెజర్మెంట్ తర్వాత క్లాస్ పెట్టుకొని ఇక్కడ క్లాస్ పెట్టుకొని చూస్తే ఇక్కడ సీన్ టైం వేరియేషన్. మీరు ఇక్కడ ఉండే అబ్బాయి కంటే కూడా అక్కడ ఉండే అబ్బాయి తక్కువ ఏజ్ మాది ఓకే. సో యూ హ్యావ్ ద టైం వేరియేషన్.
Sir, I also have also one question, sir.
Yeah.
No, sir, normally elements here exist in gaseous state. Let's take noble gases, sir. They always exist in gaseous state due to the Earth's atmospheric conditions. But when we get into the space, do they exist in the same state, that is gaseous state there? Let's say for example like xenon, here it exists as gas. If we go to the space or some other planets, does it appear in the same state there, sir? Are there any possibilities that it can exist in solid state or liquid state?
Actually, the complete universe is made up of, as you will all try to understand, that it exists in 4 states. 4 states. So one is solid state, liquid state, gaseous state, and plasma state. Okay, it's also very important plasma state. Of course, in next stage there are elements. We understand that 4 states is something. Now we can just observe that the environment in the gaseous state will have many elements. For example, oxygen, carbon dioxide, nitrogen. How you are differentiating this one? Oxygen, for example, if you take the atomic number is 8, atomic mass 8 is 16. Okay? If oxygen is existing in mass also, say for example, which is not available now, that's a problem. There is no oxygen. And xenon, for example, if say for example, and what is meant by this atomic number 8? What is mean by this atomic number 8? That means when you just consider an atom which is consisting of a positive nucleus and the electrons are revolving around it. That means it is consisting of 8 protons and 8 neutrons at lower level. Okay. And 8 electrons are revolving. Okay. This is there. That means if the same number of atoms, the atom which consisting of 8 protons, then it will be, we can say that the oxygen is alpha. If it is cannot say, for example, depending upon the atomic number, whether it is existing or not. That's why what people will do is the thing. When you send an IR beam, infrared beam, and then it interacts with the environment here, and it comes back here, you can see the binding energy between the two molecules. For example, there are molecules or carbon dioxide molecules. We give a separate orientation. That means the beam will just go interact with this binding energy and comes back. Another beam comes. If both are in phase, that you can see a signal there. This signal, the binding energy signal, we can say it's the binding energy unde. So this atom will be animal property of the animal. And that's what people will do. So to get the signal, until from picture signal, for example, 1 line beam of the race 4 line. That to Malabashi for views there. And just, for example, that not even 1%. It's maybe 10 to the power of minus 3 or 10 to the power of minus 4 fraction. A signal in our catches can amplify just to an day. A binding energy calculation is binding energy calculation to the possible data.
Then the state reaching.
For example, uranium 92 to 92 in the atomic number, and 92 number of protons are there in the nucleus here. And this proton, so the binding energy is different. So binding energy for hydrogen, for oxygen, for uranium, and for different elements is different. So how you are calculating binding energy? Binding energy you can calculate by immediately it absorbs and then sends to the flashback. And you can just see binding of Raman static or fluorine infrared spectroscopy, you can just mention.
Thank you, sir. Thank you for another explanation.
Even what we just do here is for identification. For example, your teacher, she did on vanadium pentoxide. Vanadium and oxygen. Vanadium oxygen, it is vanadium pentoxide V2O5. And that is 2 kinds of vanadium and 5 oxygen. So it forms like a structure. Okay, for one molecule. If now you use your own spectroscopy or LTIR to confirm that what the sample that you have synthesized is the vanadium pentoxide or not. Okay, so this is the advantage. Yes. Yes, sir. What? Yes. Yes. See, I think it will done in many ways. Oxygen is one point where the particle is spread there. So the molecule that's why it is going on. And it is the reaction of nuclear fusion and nuclear fusion. Okay? So, when two nuclei, for example, hydrogen and hydrogen, see that forms like helium. Okay? Hydrogen 1 plus hydrogen 1. So it forms like helium, and helium is split into 3 again. So, nuclear fusion and fission programs that are being continuously, the reactions are being taking place, and the energy is coming from the nuclear reactions. The nuclear bomb. The waste energy don't require oxygen. Oxygen is not necessarily there. It is the nuclear reaction, fission and fission reactions which are very important. all the time, which is a well founded. And then bigger nucleus, it splits into two smaller nuclei. And two smaller nuclei, once again, they will merge and then become here. So it's a continuous process that is going on. Understand? That depends upon, for example, moon by చూసారు మూన్ పైన కూడా ఇప్పటి బాగా ఉంటాయి బండలు ఇవన్నీ ఉంటాయి దానివల్ల ఏమన్నా ఐరన్ ఉండొచ్చు జింక్ ఉండొచ్చు తర్వాత ఇంకేమైనా ఉండొచ్చు కదా కానీ అప్పుడు ఎలిమెంట్స్ ఉంటాయి ఏది ఎక్కువగా ఉంటుంది ఏది తక్కువ ఉంటుంది నాకు చెప్పలేదు ఇప్పుడు మన తిరుపతిలో ఏమన్నా ఉన్నాము ఇక్కడ మనకు గోల్డ్ లేదు అక్కడెక్కడో పొలాల దగ్గర గోల్డ్ ఉంది ఎక్కువగా ఉంటుంది ఇక్కడ కూడా మిగతా ఎలిమెంట్స్ అన్నీ ఉంటాయి మీరు ఇంట్లో చూస్తే ఇవి కాదు సోడియం పొటాషియం తర్వాత వచ్చేసి ఐరన్ space లో అయితే space లో what happens here? Space ఇక్కడ మనకు atmospheric pressure is 760 mm of space. You all know. And ఇక్కడ మనకు that this atmosphere which consisting of the gases of oxygen maximum. So you can say nitrogen is 78% and you have oxygen 8% and the remaining other gases helium, carbon dioxide, sulfur dioxide, ammonia, all these things are available here. But if you see on the moon, that the nitrogen and oxygen percentage is very minimal. And it's like a vacuum. That's why there is no, because here there is no atmosphere. And that is, we can't say no atmosphere, but it is a reduced atmosphere. Reduced atmosphere. For example, for example, you create vacuum, for example. That the vacuum is, say, for example, 1 charge is not. The 7 mm, you have 760 mm of atmospheric pressure. 1 mm low vacuum low the number of particles to decrease. Avogadro program, that is for 23 number of moles per node and molecules per node. I think they do say now, after the elements and it, after స్పేస్ లో అయితే మనకు చెప్పలేదు అందుకోసమే ఎక్కడన్నా ఇంకొక ప్లానెట్ లో దీనికి సరిపోయే ఆక్సిజన్ ఉందా అనేది నాకు ప్రాబ్లం ఇప్పుడు మనకు బికాస్ వీ హ్యావ్ 70% ఆఫ్ వాటర్ అండ్ 30% ఆఫ్ ల్యాండ్ అండ్ యూ కెన్ ఏబుల్ టు సీ దట్ ది వాటర్ ఈస్ ఆల్వేస్ దెన్ వి జస్ట్ వెన్ వేపరైజ్ ఇట్ కమ్స్ టు ది హైడ్రోజన్ అండ్ ఆక్సిజన్ అండ్ తీసుకొని వచ్చేట్టు ఫర్ ఎగ్జాంపుల్ ఇట్ టేక్స్ అంటే రిలీజెస్ CO2 తీసుకొని రిలీజ్ ది ఆక్సిజన్ ఈ ఎన్విరాన్మెంట్ కావాలి అంటే నీళ్ళు ఉండాలి నీళ్ళు ఉంటే ఆక్సిజన్ ఉన్నట్టు అందుకోసం మీకు హౌస్ సర్చింగ్ ఫర్ హైడ్రోజన్ ఆక్సిజన్
Sir, what are the other important contributions for the today's physics students for the future scope of space exploration?
It's a very difficult question. Possibilities are there. Contributions for further. No, we need now the power launching vehicles. That means we are just controlling because it has to go geostationary by means of overcoming the స్పీడ్ తో పోగలిగితే ఇప్పుడు ఏం కావాలి మనకు 2 things are very essential. People are now doing it one side that the material which is being used for the satellites must be able to sustain for very high temperatures and high pressures. That this turbo engines must be precisely controlled. Must be precisely controlled their speed. Consistency very important. What is engines being tested up to అలాంటి మెటీరియల్ కావాలి. నిన్న ఒక నా స్టూడెంట్ వచ్చాడు మెకానికల్ ఇంజనీరింగ్ అతను ఈజ్ వర్కింగ్ ఇన్ USA ఈజ్ వర్కింగ్ ఆన్ ద ఏరోడైనమిక్స్ ఆఫ్ ది సర్కోపల్స్. ఈ ఏరోడైనమిక్స్ చూపించాలన్నమాట ఒక ట్రైన్ కూడా. You can make a turbo pump with 100 kilometers per hour You can make a turbo engine which can say 1 lakh kilometers per hour. You can make a turbo engine which can rotate with light speed. But the biggest problem is to move such a speed, the temperature developed at that particular point is very, very, very high. And the pressure constraint is further one. So the material which you use for the generator application requires first sustainability. For example, tungsten. We have tungsten. 3,400 degrees making temperature. But if it is the people are now making the monitor something like that, these are the metal lines. These are the metal lines. But if it is 10,000 degrees, then you get a material to sustain for that temperature. This is one thing. You can see that the temperature is something like thousands of degrees, 5,000 degrees, 1,000 degrees of the ground. And our temperature is
26 26 తీసేసేనా మళ్ళీ పర్ఫార్మెన్స్ షూట్ చేసేసి ఆఫ్ చేసేయచ్చు ఆయన ఆపితే ఎవరో ఒకరు చూస్తున్నారు 7 లైక్స్ ఉన్నాయి
This is another constraint. And the third constraint maybe it is because the transformation technology.
Seniors.
This transformation technology is very, very important because the energy that we are in the form of sound waves, electric waves, electromagnetic waves, from one form to another form, though it is very, very small signal, it must be able to transform. So in more development that the opposite is now. So our is the constant. How people are working with this particular. High speed computers from computer lab to the RAM, it's going like say for example now the quantum computing. People are now expecting the Madhyakamalo చూసారంటే కనుక qubit system లో రెప్రజెంట్ చేస్తున్నారు qubit system and ఇప్పుడు qubit system now the aim of our they are going for 50 qubits so they are but already people have developed about I think 500 600 qubits local but laboratory level but exchange is a problem because it has to be maintained at low temperature. Maintenance of the low temperature, 0 degrees is very, very hard to understand. Okay, these are the constraints. And the maintenance environment and the sensor capability and the material to withstand for high temperature and high pressure. These are the constraints. And people are you cannot separate the satellite with the robots. All the robots are inbuilt there. వాళ్ళు ప్యారల్గా మనుషులు ఉన్నా కూడా వాళ్ళు they will keep one robo and then you are seeing how the technology includes that but now you have the robots now. You can fix the program and then you can run it. I told you that you can have a small robo of your knee size or less than knee size.
ఇంకా మిడిల్లో వెళ్తాం
body and then you can do surgery and then comes back. So robots are not separate now. Now I think maybe after 10 years it becomes one life partner. Because you would say robo missionary after వచ్చేసి చాలా చీప్ మీరు you can have some 50,000 rupees you can have a robo and which means the complete house and it takes everything. So robots are not distributed. Robots require these gadgets. అంటే రోబో మూవ్ కావాలంటే దానికి పంపు కావాలి, పంపింగ్ సిస్టమ్ కావాలి, మిషన్ కావాలి. అండ్ మీరు సిగ్నల్ అది రిసీవ్ చేసుకోగలగాలి, అది సెండ్ చేయగలగాలి. అంతేగా మీ రోబోట్ ఇలాంటి సక్సెస్.
Thank you, sir. Thank you so much. Sir, ఒక్క నిమిషం సార్. సార్ ఒక్క నిమిషం సార్.
సార్ మా గురుగారని చెప్పాను కదా.
Yes, ma'am.
నా పేరుకి ముందు డిఆర్ రావడానికి డిఆర్ రావడానికి సారే కారణం.
क्या
ఓం నమో వెంకటేశాయ.
ओम नमो वेंकटेशाय.
ఉమా మేడం. సార్ ఒక కూర్చో. ఉమా మేడం ఒక పర్మిషన్ ఇస్తే, అలాగే సార్ ఒక పర్మిషన్ ఇస్తే జస్ట్ 2 నిమిషాలు సార్ ఒక్క నిమిషం సార్ గురించి మాట్లాడతాను. నాకు యాక్చువల్గా నేను ఇక్కడ కాదు మా పీజీ చేసింది. సో నాకు ఎస్వి యూనివర్సిటీ గురించి కూడా పూర్తిగా తెలియదు. డిగ్రీ వరకు అప్లికేటెడ్ బై ఎస్వి యూనివర్సిటీయే. కాకపోతే పిహెచ్డీలో నేను పీజీ సెట్ రాశాను, క్వాలిఫై అయితే అయ్యాను. సో కాకపోతే ఎస్వి యూనివర్సిటీలో ఎవరు తెలియకపోవడం వల్ల ఎవరి దగ్గర పిహెచ్డీ చేయాలి, ఆ సీట్ ఎలా తీసుకోవాలనేది కూడా నాకు తెలియదు. కాకపోతే అప్పటికే నేను SPW కాలేజ్లో ఫిజిక్స్ ఫ్యాకల్టీగా చేస్తున్నాను కాబట్టి నాకు అటుపక్క ఇటుపక్క ఉండి ఉమాదేవి మేడం అలాగే జయశ్రీ మేడం ఇద్దరు నన్ను తీసుకొని ఎస్వి యూనివర్సిటీకి వెళ్ళడం జరిగింది. అలాగే మా హుస్సేన్ సార్ మా గురువు గారు ఎప్పటికీ కూడా నేను చాలా రుణపడుతుంటాను. సో జయశ్రీ మేడం అలాగే ఉమాదేవి మేడం సార్ నాకు అప్పుడు ఇచ్చిన ఇప్పటికీ ఆ అభిమానం పోదు. అసలు నేను ఎప్పటికీ సార్కి అలాగే ఉమా మేడంకి జయశ్రీ మేడంకి రుణపడుతుంటానమ్మా. మా సార్లు చెప్పడం కాదు. సో ఏ ల్యాబ్లో ఉన్న రీసెర్చ్ ఫీల్డ్లో వెళ్ళేటప్పుడు ఎంతో కొంత ఖర్చు పెట్టాల్సి వస్తుంది. అది మెటీరియల్స్ కావచ్చు, క్యారెక్టరైజేషన్ కావచ్చు, కొన్ని టెక్నిక్స్, అనాలిసిస్, వీటన్నిటికీ కూడా కొంత ఖర్చు అవుతుంది. కానీ మా డిపార్ట్మెంట్లో మా సార్ ఉండగా ₹1 మీరు ఖర్చు పెట్టారు. సార్ ఎంత కమిటెడ్ అంటే కమిట్మెంట్, డెడికేషన్ ఒకటని చెప్పలేదు. అన్ని సుగుణాలు ఉన్నాయన్నమాట. ఇప్పుడు కూడా చూడండి, మామూలు జనరల్గా అయితే మీకు ఫార్ములాతో సహా వివరించి చెప్తున్నారు, అవునా? అక్కడే అర్థమైపోతుంది మేడం. ఇప్పుడు మనం అంటే అక్కడ ఫార్ములా అయితే 1 నిమిషం పడుతుంది. సార్ ఈ ఫార్ములాతో తర్వాత అన్ని కూడా అంతా నీట్గా ఎక్స్ప్లెయిన్ చేసేవాళ్ళు. ₹1 ఖర్చు పెట్టుకున్న మాకు PhD అనేది కంప్లీట్ అయింది. సార్ ఎప్పటికీ మర్చిపోలేదు. ఎందుకంటే నా పేరు ముందు దిగాల్సిందంటే అది సార్ వల్లే. సార్ ఎప్పటికీ కూడా నేను మర్చిపోలేదు. సార్ ఎప్పటికీ వెళ్ళిపోతుంటాను. థ్యాంక్ యూ సార్. థ్యాంక్ యూ వెరీ మచ్. నెక్స్ట్ కల్చరల్ ప్రోగ్రామ్ స్టార్ట్ అవుతాయమ్మా. మనకి కోరణ సెకండ్ మైనర్ ఫిజిక్స్ అమ్మాయి.
మిడిల్లోకి రావచ్చు కదా. వస్తాం.
మాట్లాడుకోవడం లేదు కదా. చాలా బాగా చేశారు, వెరీ గుడ్ నాన్న. ఇప్పుడు ఓట్ ఆఫ్ థ్యాంక్స్ బై రెడ్డి విద్య ఫ్రమ్ సెకండ్ BSc ఫిజిక్స్ హానర్స్.
చూడంలో మైక్ మార్చ్, మైక్ మార్చ్, అది ఆఫ్ చేసేయి. ఆకలి అవుతుంది దాడు, మాకు మెస్ అయిపోతుంది.
Good afternoon, sir. Respected all members. Sir is professor and belonging to physics department in SPW University. And lecturers and the students. So on behalf of presence of everyone today, so we, sir,
శివులైతుంది.
sir, we heartfelt gratitude to
దీన్ని పోస్ట్
giving
చేయి,
time for us, sir,
దీన్ని
and
పోస్ట్
giving the
చేయి.
valuable insights and encouraging
గ్రూప్లో లింక్ పెట్టి.
messages and also the inspiring words to us, sir. And we are grateful to have the
బ్యాక్
presence
ఎందుకు
of you,
వస్తున్నావు?
sir, and
షేర్
and sharing your knowledge and sharing your knowledge and having the experiences with you, sir. And